selamat siang, selamat sore, right? Selamat sore. Good afternoon for everyone. Okay, let me time myself so I don't run over time. 2:20. I have 25 minutes. So the bad news is that it's probably going to be the most boring presentation you're going to have in this afternoon because I don't have slides. I don't have shiny slides. So what I'm going to do instead, I'm going to walk you through the live coding part of things. But my topic for this session is data science and using machine learning for cybersecurity and for network monitoring and things like that. So we talk about machine learning. So we're going to go into a little bit of mathematics. We're going to go a little bit into coding, but I don't have slides. So everything we do, we have to do from scratch, and hopefully they give you an idea of how it's being applied. Okay, so I'm sure throughout the last 2 or 3 years, if you've been in the industry, you see a lot of you've been to a lot of trade conferences, and you see a lot of brochure that talks about AI, talks about machine learning, and sometimes you wonder, are they real AI? What do they do, right? What is the actual application here? Which component of that is actually AI? So I work for a data science school, so my job is into those areas. So I work with a lot of financial institutions, with bankings. We do consulting for companies as well. We do training for companies as well. So without further ado, I'm going to go into it. So I'm going to be using primarily the language Python and R. So if you have done any kind of work in the past using Python and R, you probably looks familiar. But because I don't have too much time, I'll probably just choose one and I'll stick to that. And then I can take some questions in the last 5 minutes. Okay. So I want to just open up. I said I don't have slides, but actually I do have one that I can need everything first too. Okay, so let me make sure this is full screen. Okay, so for the most part, this is the design of the talk. Okay, we're going to focus on applicational. So we don't want to talk too much about the mathematics. We do need to go into a few of those, but we're trying to focus on applications. Okay, so when we talk about cybersecurity, for example, we look at multiple areas. But for this presentation, what we're going to do and the kind of code that we're going to produce are going to be focusing on at least the 4 areas. Okay, so we look at prevention, detection, diagnostic, and we look at post-incident reporting. Okay, so which is a very important part of cybersecurity as well. You need to be able to report and be able to share that. So moving along, sorry I have to do this a little bit faster. I need to make sure I'm within the constraint of the time. So let's look at the first one. Okay, I'm going to walk through so this is the first one. We're going to focus on machine learning in action. So what I'm going to do is I'm going to write some code and run through the logic of that, run through the logical constructs of it, and then we're going to look at how do we monitor, how do we help network security experts or engineers do their job better? How do we complement them, right? How does machine learning comes into it, and what kind of value add do you bring onto the table? So network security monitoring. So let's talk about that. Let's start with that. Okay. So and just to make sure, I give you the context. So this one is basically the case study is a network traffic classifier. This is not an original idea. I didn't come up with the idea. I stole it from Cisco. So they wrote a blog post about this. They said. So a lot of times you hear people talk about machine learning and AI, but not a lot of people document that work, and not a lot of people make them available. And not even less people would try to explain that, because most times the people who are writing that, they're marketing folks, right? They don't know how to explain that. So Cisco has a blog post about this. It says that this is what they attempt to do. They have a very short article about how they use machine learning to analyze network traffic and predict the source or the destination just using the pattern of the traffic. Okay, but within the article itself, there is not a lot of technical details. They didn't talk about what kind of packages, what kind of how do you go about doing that? How do you collect that? How do you analyze that? They didn't talk about that. So what me and my team did was we said, okay, look at the article. What if we document all of that and we reproduce the whole thing? So we started with, anyone heard of Wireshark? Anyone heard of Wireshark? Can I see a raise of hand? Okay, most of you. I would say about 30-40%, a lot of you heard of. So we started from that. We said, okay, what if we look at the raw data, which is Wireshark, we look at that and we collect data from that. So imagine if you haven't heard of that, some of you have, if you haven't heard of that, imagine working in a company and you connect to a certain Wi-Fi on the 10th floor. Okay, you work on the 10th floor, you work in the finance department and you are in you're located on the 12th floor. So you connected to the Wi-Fi on the 10th floor, and what the IT team does is that they provide the modem and the infrastructure for you to connect to the internet, and network monitoring is to study that, right? So look at that traffic, and then how do we make sense of that? How do we extract valuable insights out of that? So I'm going to just go right into the code area and to show you what I mean by that, okay? So a little bit of background before we do that. So because we're focusing on machine learning, let's come up with a definition of that. So I want to put aside all of the hype. I don't want to talk about, you won't hear me use the word AI. So I'm going to use machine learning for consistency. What I'm going to do is we're going to look at this. How do we define that? When is computer programming machine learning? When is it computer programming? When is it machine learning? When is it normal software engineering? Right? When is it not? Okay. So a lot of times when we work in cybersecurity, what happened is that we have human experts program the rules, right? We said, okay, if you look at this, there is a phishing attack, you do this. If there is an outbound, if there is an open port, what do? Like humans program the rules, and when human programs the rules, the computer execute the rules, and they do it flawlessly, right? So human come up with a set of rules. Who are those humans? The experts, right? The guys that works at ITsec, right? They are the experts. In machine learning, we twist that formula a little bit. We said actually humans are not very good at defining rules in some cases. So what we do is that we get the machine to define rules, programming it. Okay? If that makes sense. So this is the distinction between traditional computer programming, computer science, and machine learning. Now, in the art of machine learning or in the science of machine learning, what we do is that we don't give any explicit instruction. Instead, we give it patterns, we give it data, and we say from that data, infer. Through what? Through Bayesian model, through probabilistic model, through mathematical model, through a if you learn about calculus and you said, okay, there is an optimization algorithm called a gradient descent and stuff like that, do I use those things? Yes. But the machine is there to figure out through mathematics. Okay? So human doesn't program the rules, machine is going to define the rules. So So one example of that is this. For example, is that, let me zoom in a little bit more. So let me just play it. So if you were to see what the machine learning model is doing, is that human doesn't get to write all of these rules anymore. What the human do is that human put all of this data and said, okay, I want you to learn from that model. So what the model is going to do, what the algorithm is going to do is that it's going to look at that and it's going to come up with the probabilities. It's going to start from there. So for example, it says, okay, what is this? Is this an incoming port or outgoing port? If it's an incoming, what is this? Is this through a UDP or through a TCP or through a whatever it is? And then it goes down. It follows a set of rules, but no human create the rules. If you interfere with this, it's no longer machine learning. It's human learning. Okay? If you come in there and say, no, actually, what I really want is for you to look at this again. If you put in any kind of human logic in there, it's no longer machine learning. So that's the strict definition of what machine learning is. Is that human don't interfere, human only give the data and hands off. Okay, your job is done. The machine, through a optimization algorithm, would find out how do you minimize the risk or how do you minimize the threat. Okay, does all of that make sense? Is that all clear? Okay, so now in machine learning we usually hear about terms like supervised learning algorithms and we hear about unsupervised. So today what we're going to do is that when we're going to go into the the network monitoring, we're going to use the supervised algorithms. So this is roughly the process. Okay, so we look at hypothesis, we form a hypothesis, we collect some data, we clean up the data, we do some feature engineering, we explore, we construct the model, and we test the model against unseen data out of box. So OOB. This is very important in machine learning, and a lot of people don't feel to do that. And they're actually not just even not even just practitioners, not even just industrialists. Even scholars will sometimes fail to adhere to the kind of rules. So what is it important that you test against out of the box data? So the reason for that is that if you were to test against data you train on, most likely you're going to be overly optimistic. Meaning if you build a model using this set of data and you test it against this set of data, it's not surprising you can get very good results because it's already seen the data. What is important for a machine learning model is to be able to generalize. Meaning this is the data, you only expose it to the first 80% of data, you train it, and then with that model you test it on unseen data. That's out of box. That gives you the confidence that this model, when you deploy it to your client services, would work well on their data because you haven't seen the data. Okay, so that is important in the case of evaluating its performance and evaluating its generalizable ability. How does it generalize to unseen data? Okay, so generalize to unseen data. So that's kind of an important idea in here. So what we would do is this: we would try and test it. We would download a lot of data from. We look at all the packets from Wireshark. Look at all of that. We train it. But when you try to test it, you don't go back to the same data. You ask another guy who bought a new laptop, came to the office, say, "Okay, connect to the Wi-Fi now. Connect to the Wi-Fi and start browsing websites, and I will try to predict what are you watching without installing anything on your computer." Okay. So you have a new guy bought a new laptop in the same office on the same 12th floor. Sits on there, starts to browse. What you have is you have the packets. You don't get to install anything. You don't get to touch the laptop. But you have to predict what is it that this guy is browsing right now. You can say, okay, my model guess that you're on YouTube right now. And he will tell you whether he's right or not. You have to go on unseen data, on out-of-box data. I don't think I have time to do this now, but I'm pretty active on Stack Overflow. If you have any question, you can ask me there. But the case looks like that. So the model will learn and learn and learn, and from learning, and this is surprisingly easy to do in Python or R. If you learn Python, if you learn R, with enough data, you can build a pretty robust model in less than 20 lines of code. So it's not very different from the kind of programming you do, say in a shell or say more conventional programming languages. So what it will do is that it looks at all of those things and it comes down to a certain probability. So it estimates. Okay, so now let's go into the actual data. So now that we have a bit of understanding, I know it's not ideal. I know ideally you want to have more background, but unfortunately, sorry, not this one. Okay, so I have some materials ready. Some of them are in English, some of them are in Bahasa. I hope you don't mind, but I'm just going to run that through very quickly. Make sure all of this is run. Okay, so the idea is this is the Wireshark interface. Okay, this is a software that is very familiar to many people who work in that field, network monitoring. So if you open up Wireshark, and I don't think you want to do that right now here. So when you have access to that, you start to look at traffic and ports. So you have things like the source, the destination, and then you have packets. Now most of these packets doesn't make a lot of sense, but that's because to a human eye, this is how a packet looks like. So if somebody hits, this is all in milliseconds. So we're looking at using the first 50 milliseconds. And so 1 second is 1,000 milliseconds. We're only looking at the first 50 milliseconds. So when somebody hits, let's say, hits a website, whether it's a phishing website, for example, if he hits on a phishing website at time t, from time t plus 50 milliseconds. So it's less than 1 second. Okay, it's not 50 seconds, it's 50 milliseconds. Okay, less than 1 second. So from time t to plus 50 milliseconds, this is the packet that is being transferred. Okay, from him clicking on that email. So let's say you have a HR, not very familiar with technology, doesn't know what it is, click on that and said, okay, the email comes in and said, please pay this vendor. She doesn't know it's a scam. She doesn't know any of this stuff. So she clicks on it and goes to the website. In the first 20 or 50 milliseconds, so this is data every 10 milliseconds. This is a network packet. Now for a human, for a trained expert, no matter how trained you are as an expert, you can't probably just look at this and say, okay, I kind of know this is a phishing website. You can't really know that. You can't really look at this and say, I know this is a DBS website. You can't really know that, right? This is just a pattern, doesn't make sense to a human eye. To a human, this is not a lot of value. But to a machine, to a mathematical model, this is a lot of value. Because if it has enough of this pattern, the mathematical model will start to recognize when is this website A, when is this website B, when is this website C, and so on and so forth. For a human, there's not a lot of value. If I send this to you, I send 1,000 of this to you, you won't find a lot of use out of it. But for a model, for a mathematical model, it is very useful. So, sorry, I know I have to go a little bit faster, so I can't go into all of the details. I ideally wanted to do this like live, but and then okay, let me run you through the code at least, okay? So the data, where do we get the data from? Let me open up again, right? That's if you go on to using any of your network sniffing tools, just go get them. And then we basically just created all the folders, and we have all of these packets saved as each one of them. So here we have 100 network patterns from, let's say, Spotify, and then we have 100 network patterns for YouTube. And so we have all of this. So imagine you have a big folder of all the suspicious websites, all the legit websites, the internal company's website, all of this. So you have those patterns, and then you train the pattern. How do you train the pattern? And reading them into it is really easy. You just read those CSV and then you just read them, or you iterate them. Just write a for loop, and then for each file within the directory, read the bin. And then what you do next is that you try to analyze that. I split the data to 70-30% training. So again, it's important that you do that, is that you take only 70% of your data to train it. Meaning the 30% you hold it out. You don't want to train it on that because you want to test it. Okay? So you take 70% of data, you say, learn to recognize the patterns from this 70% of data. The remaining 30%, I'm going to take it to test you. So you don't get to see it now. And later on, we use this method called random forest. Random forest is a very powerful algorithm. It's used, what it does is that earlier you saw the tree, the Stack Overflow tree. You saw this tree earlier. Now this is one tree. What a random forest is a combination of hundreds of thousands of such trees. So it's not one tree, it builds, at the very minimum, the default, if you don't change the parameters, a lot of packages would by default build 500 or 5,000 trees. This is only one tree. So imagine 500 of them, and each one of them would try and estimate the chance, and then they assemble them together to vote and say whether or not it's a fraud. Okay, and I'm gonna go back to this, and then what it does later on is that we will test it on the out-of-box performance. I'll skip into that and I'll show you this, but you can see on the y-axis is the error. So this is the error you're making, and then this is the amount of trees that you have. So even at about 200 trees, you already have pretty good performance out of the box. This is out of the box, okay? Out of box, meaning it's testing against real-world conditions, not against a test environment, okay? Against out-of-box environment. So even at 200 trees, you already achieve pretty significant results. This is the error 0.1, and you're below that, meaning your performance is above 0.9, 90%. So, and you can start to estimate its accuracy, its sensitivity, its specificity. Okay, so you can try and evaluate them and see how would they perform. You can also try and see when there are false positive rate. For example, if the HR actually clicks on something that is legit, but your model predict that this is, oh, she clicked on a phishing email. That's a false positive. So you can also try and estimate that, again, using unseen data. Okay, so that's the first part of that. I'm sorry, I really don't have too much time to go into each one of them in detail, so I'm going to have to go into the second one. Oh, the second one is talking about this botnet. Okay, so one thing you can do, what do you need to learn, like Python and R and stuff like that, to complement your cybersecurity guys, right? Why do you have data scientists working in the same team as the cybersecurity folks? Why do they need to learn about Python and R in order to, what value can they bring to the table? So one idea of data science is that you can very quickly extract data, feature engineer data, and extrapolate from existing data. So one example I'll show you is very quickly, I'll show you a list of block lists, IP addresses. This is just very simple, it's just a set of IP addresses. There's nothing fancy in here, okay? So if you look at the dimension of this, okay, this is 113 rows, 1 column. So there's only 1 column, just to make sure we are all understanding that. Okay, there's only 1 column. So this column is just a simple column that contains IP addresses. So you have a set of IP addresses that let's say you work with one of the big, very good companies. All of these guys, the presenters before me, right, they presented all the solutions. A lot of them, in some form, they try to capture and they try to produce this. You can extract them and then you load them into Python or you load them into R. I'm using R here, but you can do the same for Python, and I have the materials up there online. You can go and get them. But once you have these IP addresses, there's only 1 column. How do you feature engineer out of that? How do you extract data from that? So very quickly, I'll show you a couple of tricks you can do. One thing you can do, for example, is that from one IP address, you can very quickly look at from this IP address, I pass in 1 parameter. Okay, 1 parameter, and from there, I go into the AS, I go into the BGP, and all of this stuff you can Google. So you can just type AS and pass this in, and you can see who owns that. And some of this has API that you just connect to, and you can just find out straight away. You can click on that, and you can see who is the organization, where are they based in, how many addresses are allocated. Most of this time, you don't have to do this manually. There are good APIs that you can use, and some of them are free up to a certain point. And I think a lot of the vendors out there, like the one you see in this summit, they would also have access to that. So you take that, very quickly we take this IP address and we feature engineer out of that. Very quickly we want to find out, okay, who is the registry? There are usually 5 big registry. It belongs to one of these big registry. And this is of course working on IP version 4. If you're using an IP address version 6, very similar flow, but you modify a couple of code here. So another example, you can see here, for example, I was doing this talk in ITB actually, so we were doing this live in ITB, so I had 3 hours, so I can do this line by line and I can explain this, but here I have 20 minutes, so I don't want to go into line by line. But very quickly you can take one of this and then you can go from there again. You can now see, okay, who is it assigned to, who is the registrar, and you can look at the data. You can see this is allocated to ITB in 1993. And again, all of this information are public. Usually you just have to Google them. Like for example, you can see these BGP prefix, you can Google them. You can look at ASN info. And so what I'm going to do is I'm going to take that 1 column and quickly use the same technique, and this one I need an internet connection because it would actually have to query that and pull that back to me. So while I'm connected to internet, it will pull that out for me, and now I can see a list of them. So I can see where are they coming from. When they're trying to access my server, are they from, you can see some of them are using a Chinese server, Indian server, Indonesian server, Thai, US, so on and so forth. And then, skip that one. And then very quickly you can start to visualize them. Now you can start to visualize all of this. Okay, so say you have and this is actually using the botnet data that we were looking at just now. So the Zeus botnet. If you don't know if you need a bit more context, you can just type Zeus botnet, and I guess you can type wiki, and I guess you can just read up on it a little bit. But a lot of you are familiar with this. Some of you, if you're not sure what I'm talking about here, you can look at that. You see, this is at the time it was pretty rampant, right? They estimate that this has become the largest botnet on the internet, infected 3.6 million PC in the US. So very quickly we take all of the IP addresses, we take them, and then we start to visualize. We say where are the clustering from, and you can see all of these IP addresses and whether or not they share the same server, or whether they are located in the same place, and you can cluster them very quickly. And then again, if you're using Python or R, you can very quickly call up tkplot. You can change the layout. You can export them. You can play around with the network. You can really try to understand and identify. Also, network graph is actually very commonly used, not just for this. Network graph is also used to identify robustness, to test for robustness. So for example, we're talking about defensive here, but let's say you're on the offensive. Now, if you're on the offensive, one of the things you look at is that you say, okay, if you only have the resources to bring down one core, all of these are called nodes, right? Each of these are nodes. So you can think of them as server, or you can think of them as any kind of web service, online service. Now, if you can bring down one service, what is the one service you can bring down that causes the maximum disruption? What is the one service you can target that brings about the maximum destruction? So if you can bring down this, you disrupt only one service. You bring down this, you disrupt 1, 2, 3, 4, 5, 6 service. You bring down this, you disrupt 2 service. Then there is one obvious service. So you can use that to also identify and visualize and see how much dependency and how much redundancy you have. The more redundancy, the less vulnerable you are to offensive threats like that. Sure, I don't think I have any more time. I think I should be wrapping up soon. The last one is, anyone use GitHub? Yeah, okay, a lot of you use GitHub. So some of these materials are actually on my GitHub. If you want to go and study them a bit further and stuff like that, you can. I also have a few packages on R and Python that you can also use. So very quickly, you can download this for free, and you can just go and open up R Markdown, and you can say demo, open that up. I'm going to delete all of this. Just going to do the last part. I won't have time to cover all my materials, but let's try and do at least one of them, okay? So usually you can see a lot of these have good documentation. So I already installed that, so I'm just going to load the library. So I'm just going to load library and put it in here. Done. And then, whoops. I'm going to load the data in. This is just one line of code in R. See how simple that is. In Python and R, most of this stuff are really simple. One line of code. Even if you've never programmed in R or Python, you can see them and you understand them. Most times I find it that way. Let's look at the dimension of the data. Let's see how many rows and how many columns of the data there is. Run that. 8,200 rows of data, 2,436 columns. I'm going to skip all of this pretty much. I'm going to skip all of this. I can do this. Because all of these are on my GitHub. If you want to study them on your own and stuff like that, feel free to do that. But you can now, there is a framework to report and to collect all of these incidents and report them together. And this initiative is initially started by Verizon, by the security team, the cybersecurity team that work at Verizon. And I created some packages that helps you manage those things. You can look at what kind of assets are compromised, who are the actors. And you can see the actors, sometimes you see some of them are external, some of them are internal. So for example, you have former employee, you have nation state, you have organized crime, state affiliated terrorists. You can look at asset variety. And all of this, look at how simple that is. It's just one line of code. You put them in, you plug it in, you get them. You can see whether the asset that is being compromised, are they a kiosk, are they a media network person server? Whether the action is environmental, error, hacking, malware, misuse, physical, social unknown. And I'm just copy pasting my own code. So all of this, I put up all this documentation and I maintain it quite reasonably. So you can just go ahead and just do what I just did. Just open up my GitHub account, look at the projects, and then you can just sort of just copy through all of this stuff. And let's say you want to produce a pretty good plot. Again, I'm just copying that, paste that back in. Let's see what it says. Deployer. Forgot the closing bracket, sorry. So if you attach the closing bracket, you get a quick plot, and you can start to look at all the confidentiality breaches for one company, and you can look at the timeline incident. You can see over time how many timeline incidents are there. You can look at, for example, you can look at country level investigation. You can look at Indonesia, for example. I have a few, actually let's just do this, but I'll change this to Indonesia instead. ID, okay, and let's print that out, all of them. Okay, let's take a look at that very quickly. I'm just gonna try and say notes. And discovery notes. So usually you also record like how do you discover that, and you know what are the methods you use to discover that, who discovered that. So you usually have all of those data, so you really want to record them as well. So there is a framework for doing that. Let's see if we have. Let's try the last one, victim. Victim notes. $sign. Nope, no victim notes. But you can try and play around with that. But you can usually try and get pretty interesting insights about when an attack happened and stuff like that. And there is a platform for you to cross-share all of those things. It's called the VCDP community. So there are very well-maintained packages that allows you to do that. So all of these are pretty much open source, and you can use them. And you can, if you need to find a way to implement some sort of threat discovery and sharing, and also you wanna have a way to record all of these incidents, the security incidents, then you can consider that. So that's pretty much all I have. Make sure I've gone through all of this stuff already. Yeah, I think so. All right, so that's pretty much about it. But I hope that through the quick 20 minutes presentation, you get a sense of like how learning, picking up an additional skill or picking up an additional team member who is probably comfortable in a Python or in data science can help bring the kind of value that you have into a company, whether to extending your current capabilities or whether to enriching your current solutions and to add a layer of more robustness to your solutions, offer an alternative to trying to discover threats, prevent threats, study network monitoring, and things like that.